In solving the equation in example 4, we again need to take a look and find what would the lowest common denominator be. Now remember that the lowest common denominator is going to be the most of each type of factor. You can see that I have got a factor of 2x minus 1. If I don't write an exponent above that factor, it means that my exponent is 1. But if I've got that factor 2x minus 1 and it is square rooted, the square root of 2x minus 1 in fact means that I've got 2x minus 1 all to the half. In other words, the most of this type of factor is going to be 2x minus 1 to the 1. Now when I try to get rid of my denominator, I always take a look and see what denominator did I originally have and what new factors do I have in the LCD. As your very first number 1 had a denominator of 1, I must times 1 the old numerator by 2x minus 1. Going on to my next term, it had a denominator of 2x minus 1 to the half, but there is another 2x minus 1 to the half, because if I say 2x minus 1 to the half times by 2x minus 1 to the half, I have 2x minus 1 to the 1. So in other words, 3 needs to be multiplied by a further 2x minus 1 to the half. On the right-hand side, as 10's denominator was identical to my LCD, the denominator is going to fall away. Now, if I have a square root and I want to solve an equation, I try to get the term with a root on its own. The term with a root is minus 3, the square root of 2x minus 1. And so taking the other terms across to the right-hand side, I'm going to have 10 plus 1, which is 11, and then minus 2x. The method that I'm going to follow to get rid of this root is to square both sides. If I square the left-hand side and square the right-hand side, remember on the left-hand side, I actually have two factors there that I need to square. The first factor is minus 3, and minus 3 times by another minus 3 is going to give me the number of 9. The square root of 2x minus 1 squared is 2x minus 1. On the right-hand side, if I want to square this number, I must expand my brackets and multiply correctly. Now, for the sake of us remembering how to do this properly, I'm going to write it out in full. And now multiplying my brackets out, I'm going to get 18x minus 9 is equal to 121. Minus 22x minus another 22x is minus 44x. And minus 2x times by minus 2x is plus 4x squared. You can see over here I have a quadratic equation, and so I'm going to take all my information to the one side and make it equal to 0 on the other. As there is a highest common factor of 2 that can go into all three of these terms, I'm going to take 2 out just to make it a little bit easier for myself, which gives me 2x squared minus 31x plus 65 inside my bracket. Dividing both sides by 2, I get rid of the 2, and then I can do my trinomial method to factorize this expression. Using this trinomial method, I'm going to get 2x minus 5 in my first bracket and x minus 13 in the second. This means that the two possible solutions that I could have got are when x is going to be equal to 5 over 2 or when x is equal to 13. But you need to make sure that these solutions are going to be effective. As I squared both sides, I introduced a possible additional solution. I'm going to show you how you can check whether these solutions in fact work. In order to check that these two solutions can work, I take a look at the line of the equation once I'd got rid of my denominator. What I'm going to do is I'm going to substitute in the 2x values. If I substitute in x is equal to 5 over 2, I'm going to, on the left-hand side, get the statement of 2 times by 5 all over 2 minus 1 minus 3 times by 2 times 5 all over 2 minus 1. If I work out the sum, I don't get the answer of 10. I get an answer of minus 2. In fact, that means that this number, when x is 2.5, cannot work. Now we go back to the second solution we got, and we test it again. When we test it using x is equal to 13, I'm going to get 2 or times 13 minus 1 minus 3 times by the root of 2 times 13 minus 1. And very happily, if I calculate this sum, I get an answer of 10. In other words, the solution when x was equal to 10 was the only solution that I could use for this particular equation.